So, in this lecture, we want to look at the total ionic and net ionic equation. So basically for our reactions, we want to know what ions basically react and what happens in a chemical reaction. So I show you examples, and with each example, I try to explain to you what we're looking at. So let's look at different examples here. So let's start with reaction of lead to nitrate. And potassium iodide. That gives us lead to iodide and potassium nitrate. So to write the total ionic equation, you want to look at your reaction, and every reactant or product that's in the form of an aqueous, which is an aqueous solution, you want to break it into ions, because aqueous solutions composed of ions. But anything that's in the form of a liquid, solid, or gas, just because they don't dissolve in water, they don't form any ions. So after you complete your reaction, to write the total ionic, you look at the reactants and products that are in a form of solution, aqueous solution, and you write the ions for them. Now, for example, here, let's say I want to write the total ionic equation for this reaction given here. So lead to nitrate is in an aqueous form, so that breaks into ions. What ions do I expect from lead to nitrate? I expect lead 2 ions. All right. So we expect lead 2 ions. And since these are ions, they're still in aqueous form. And you expect nitrate ions. Now, in the lead 2 nitrate, you expect to have 2 nitrate ions. So when I'm breaking the aqueous solutions into ions, I take into consideration the number of ions available too. So the subscripts and coefficients are important. Now, from potassium iodide, you expect potassium ion and iodide ion. How many potassium ions? 2 potassium ions and 2 iodide ions. Now, for the products, lead 2 iodide is a solid, so it doesn't break into ions. You just keep it as lead 2 iodides. However, potassium nitrate is an aqueous solution, so I break it into ions. That gives me 2 potassium ions and 2 nitrate ions. So this is called a total ionic equation. So for total ionic equation, after you complete the reaction and balance it, anything that's in an aqueous form, anything that's in a solution form, you break it into ions. So the number of ions we have is important too. So in order to see how many ions are formed from each reactant or product, you look at the coefficients, and if you have polyatomic ions, the subscripts, or for every single element, the subscripts and coefficients become important. So anything that's in the form of a solid, liquid, and gas, they don't break into ions because they don't dissolve in water. Now, to write the net ionic equation, We're gonna look at both sides of the equation and see if we have ions that are in common, and if there are ions that are in common, we're gonna cancel them out. So here, so lead-2 on the reactant side, I don't see lead-2 ion on the product side, so it doesn't cancel out. However, I see 2 nitrate on this side, reactant side, and you have 2 nitrate on the product side too. Exactly 2 of them, I cancel them out. So 2 potassium here, 2 potassium ions on that side, they cancel out too. But the iodide doesn't cancel out because I don't see iodide ion on the product side. So what are we left out with? So after you cancel the ions that are in uncommon, you end up with lead ion, lead-2 ion, and iodide ion, which leads to the formation of lead-2 iodide. So this is called net ionic equation. Remember how when we did double displacement reaction, we said this reaction is a precipitation reaction. And with the net ionic equation, you can tell that it is a precipitation reaction, because what is actually happening here is the reaction of lead-2 and iodide ion, which produces the lead-2 iodide, which is a precipitate. Say copper oxide and nitric acid. That gives you copper 2 nitrate and water. So the goal is to write the total ionic and net ionic equation. So in order to write the total ionic, any substance that's in an aqueous form, solution form, we're going to break that into ions, and remember the number of ions are important. And anything that's in a form of solid, liquid, and gas doesn't form any ions because they don't dissolve in water. So to write the total ionic, copper oxide stays as copper oxide because it's a solid. Nitric acid, however, breaks into ions because it's aqueous. So we would expect 2 hydrogen ions and 2 nitrate ions. Now copper 2 nitrate also will break into ions because copper 2 nitrate is a solution too. So I would expect copper 2 ions and nitrate ions. And water, since it's a liquid, no ions. It stays as liquid. So this is the total ionic equation. Now, to write the net ionic equation, we look at our total ionic. And if you see ions that are in common on both sides, we just cancel them out. So copper 2 oxide is a solid, so it doesn't cancel out. Hydrogen ion, I don't see it on the other side of the equation. However, nitrate ions are in common, so they cancel out. The net ionic is going to be copper oxide plus hydrogen ion produces copper 2 and H2O. So this is net ionic equation. So let's look at another example. We want to write the total ionic and net ionic equation for the reaction of hydrochloric acid and sodium hydroxide. So it's a neutralization reaction. You expect sodium chloride and H2O. So to write the total ionic, you want to write the ions that are formed from each aqueous solutions. So hydrochloric acid is in an aqueous solution, so we would expect hydrogen ion, and chloride ion. Sodium hydroxide is also in aqueous form, so we would expect sodium ion, and hydroxide ion. And from sodium chloride, we would expect sodium ion and chloride ion. Now water, since it's liquid, it doesn't break into ions. This is the total ionic. Now for the net ionic, we're going to cancel out the common ions on both sides of the equation. So we're going to end up with hydrogen ion and hydroxide ion, which forms H2O. This is the net ionic equation. And remember how this is called a neutralization reaction, and your net ionic equation also represents a neutralization reaction. Hydrogen ion, which is an acid, reacts with hydroxide ion, which is a base. It forms water, which is neutral. So let's look at another example. We want to look at the reaction of potassium nitrate and sodium chloride, which produces sodium nitrate and potassium chloride. So to write the total ionic, anything that's in an aqueous form, we're going to break it into ions. So potassium ion is going to form potassium nitrate is going to form potassium ion and nitrate ions. From a solution of sodium chloride, we expect sodium ion and chloride ion. From the solution of sodium nitrate, we expect sodium ion, nitrate ion. And from the solution of potassium chloride, we expect potassium ion and chloride ion. So this is our total ionic equation. Now to write the net ionic, we cancel out common ions. So potassium ion cancel out, nitrate and nitrate, sodium and sodium, chloride and chloride. Now if everything cancels out, it means that there is actually no reaction taking place. So the answer to this question, if I ever give you the reaction, I ask you to complete the reaction of potassium nitrate and sodium chloride, you will write no reaction. So for every single reaction that you complete, you gotta look at the total ionic and net ionic. If in your net ionic equation every ion cancel out, then there would be no reaction. You don't expect any products. Now, you don't need to test for every single reaction that's given to you, because if any of your reactants or products are in the form of a solid, liquid, and gas, there would be a reaction. You will have a net ionic equation. But for reactions where everything is in an aqueous form, you really have to check for the net ionic and see if there is a reaction happening or not.